All right, real quick. You're getting ready. You're going to do the checkup, and you're going to do it on your own. I'm not solving it for you. I'm not setting it up. I'm not telling you how to get the answer. Let's just make sure we understand what all the terms mean on question 19, 20, and 21. Okay? 19 says a boy pulls a wagon with a force of 20 newtons on a handle 0.5 meters long. So we did some problems like that in some previous problems, okay? So we have pulling on the handle, so that's the force, and that is the length. So it's 0.5 meters. And then the force was 20 newtons. And then we also know the end is 2.25 meters higher, so 0.25 meters higher than where it's attached to the sled. Okay, does that look familiar? So we have to first solve for the angle, and then we can use that to solve for the missing vector. Okay, let's talk about number 20. They didn't give us one like this in the homework. Exactly, not exactly. It says 2 tugboats pull a larger boat with forces of, 25,000 newtons on each rope. What is the resultant force on the ship if the angle between the ropes is 40? All right, so here's the big ship, okay, being pulled by the 2 tugboats. One tugboat here, one tugboat here. Can you picture that? And this is 40 degrees. The question is, what will be the resultant going in that direction? Now, one boat is kind of pulling it that way. If this one all of a sudden let go and the rope broke, this ship would all of a sudden just be going that direction, or vice versa, if this one was pulling. But pulling together, they're pulling the ship straight this way. So we know the force in both of these ropes. We know what else do we know? The angle is 40 altogether. Here's what you need to figure out. If that's 40 altogether, then we need to actually use 20 and 20. And then the hypotenuse is 25,000 for each of them. So each rope, the hypotenuse is 25,000. We can ignore the vertical. You need to solve to find the horizontal. And you'll have to do that twice, okay? And then that's the full force going in that direction. That was a little tricky. That one was not, we didn't do any problems similar to that. But I think having the diagram will help. So we can see that we have 2 20-degree angles. We have the hypotenuse. Take that one away. Ooh, 21 is interesting. A man paddles a canoe at 6 kilometers per hour. He paddles on a river with a current of 6 kilometers per hour. What is the speed if he heads directly down? Well, what if he was heading directly down the river? Okay, so if the river is flowing this way, let's think about one with different numbers. Let's say he's with his boat, he can paddle at 8 kilometers, and let's say the water is 2. Is it kilometers? Yeah, kilometers per hour. Well, if he's paddling away and he's going 8, and he's going in the same direction that the water's going, then actually if you were on the side with a speedometer, not a speedometer, a radar gun, checking how fast he's going, his 8, which is in still water, you would have to add to the 2, okay, to see how fast he's going downstream. Turn it around. Let's say the boat's going upstream now, all right? So he's paddling this way at 8, but the water's working against him. So even though he's going 8 in calm water, the current's going the opposite direction. You get it? So you would have to subtract them to get his speed going up the stream. So they have a problem like that, but then they make it even more interesting. They say, what if the water is going at this speed, I think it was 6, and he's trying to go across at 6 kilometers per hour, okay? Well, think about what's happening then. The water is pushing this way, and he's trying to go across this way, and so he's literally going at an angle, and you can kind of visualize that happening, okay? He's not going to go straight across. If he looks from where he starts and he looks over here, he's actually going to be downstream from that by the time he hits the other shore. So you have to resolve adding these together to get the speed, which would be the resultant, and the angle. Okay? And we did one kind of similar to that back in our homework. All right. So I'm going to stop there. I think just seeing those diagrams for those few should be enough of a tip to get you going and to do well on your checkup.